Imagine a place where the pull is so strong that not even light can get away. We call it a black hole. Think of space like an ocean. Most places are smooth. A black hole is like a whirl in the water that gets so strong that even light cannot swim out. No light means dark. But dark does not mean empty. It means a very crowded matter in a tiny space. That is why the pull is so strong. Today, we will make black holes feel simple, real, and friendly to your mind. By the end, you will know what they are, how we see them, and why you can sleep well at night. A black hole is not a hole, it is stuff, a lot of stuff squeezed into a tiny ball. Around it there is an invisible boundary and we call it the event horizon. It is the point of no return. Inside you cannot send a signal out, not even light. Outside space is normal. If our sun turned into a black hole of the same mass, Earth would keep the same orbit. It would not get sucked in. The pull at Earth's distance would be the same, so black holes do not vacuum everything. They only grab what comes too close. The edge size depends on mass. There is a simple rule. For every 1 son of mass, the radius is about 3 kilometers. We call this the Schwarzschild radius. Earth's own number would be about 9 millimeters. If you could crush Earth smaller than a marble, it would turn into a black hole. Black holes come in sizes. Small ones form when a big star dies. We call them stellar black holes. Medium ones sit between about 100 and 100,000 suns. These are intermediate mass black holes. The big bosses live in galaxy centers. We call them supermassive. Ours, in the Milky Way, is about 4 million suns. How many are around us? Astronomers estimate there are about 100 million stellar black holes in our galaxy. Most are quiet. In 2024, Europe's Gaia mission found the biggest known stellar black hole in the Milky Way so far. It is called Gaia BH3. It is about 33 suns and only about 2,000 light-years away. That sounds close, but it is extremely far in human terms. It does not threaten us. We have also seen signs of medium-sized black holes. One example is in Omega Centauri, a star cluster that is likely the core of a small galaxy that the Milky Way ate long ago. In 2019, the Event Horizon Telescope gave us the first direct image of a black hole shadow. It was the supermassive black hole in galaxy M87 called M87 star. In 2022, they imaged the one at the center of our own Milky Way. That one is called Sagittarius A star, or SGR A star. In 2024, they shared a polarized view of SGR A star. Polarization tells us about magnetic fields. We now see strong magnetic fields right at the edge. This helps explain how black holes feed and launch jets. We are also watching M87 change in subtle ways. The bright part of its ring moves as the hot gas churns. In 2025, the team reported evolving polarization patterns, even flips, which show how dynamic the magnetic fields are near the event horizon. The shadow size stays the same, which matches Einstein's gravity very well. Near a black hole, gravity is strong and changes fast with distance. We call these changes tidal forces. Your feet feel a stronger pull than your head if you fall in, you stretch. People call it spaghettification. It is a real physics word. Do not try this at home. Time near a black hole also runs slowly compared to far away. This is time dilation. The closer you get, the slower your time runs. The movie Interstellar used real physics to show this effect. They worked with Nobel laureate Kip Thorne to make the visuals match real equations. The big black hole in the movie is a fast spinning one. The light bending and the bright ring looked right because of this work. Myth 1. Black holes suck in everything around them. No, if you keep your distance, gravity acts like any other massive object. Same orbit, same pull. Myth 2. There might be a black hole next door. Not likely. The nearest large one we know is Gaia BH3 at about 2,000 light years. That is safe. Myth 3. We cannot prove they exist. Yes, we can. We watch stars orbit one. We hear their mergers in gravitational waves. We image their shadows. Myth 4. Falling in makes you travel to another universe. No, that is fun in stories. We have no evidence that it happens. So yes, black holes are scary if you are a stray star that gets too close. For the rest of us, they are beautiful labs that teach us how nature works when gravity gets serious. So, tell me which part made the most sense, the interstellar part, the first real image of a black hole, or none of it? To be honest, I never understood very scientific explanations about black holes when I first tried to learn, except for the amazing visuals in the movie Interstellar. That is why I made this video in simple language. If any part was not clear, let me know. I will explain it in the comments or make another video that breaks it down better. What should I talk about next? I will be active in the comments, so ask your questions or start a discussion with me, and I will answer or make a follow-up video. Love you all. Keep watching.